Lesson for San Mateo Foster City School District. We are going to be doing a demo math lesson, 7th grade standards, on Pythagoras' theorem. So our learning objective, kiddos, is that by the end of the lesson, can you please read it with me? I will be able to and
be able to use
Pythagoras
to find
hypotenuse. Good job. Those words are difficult to pronounce. So they did a great job. So by the end, you should be able to do that. I would like you to write whatever comes up here in your interactive notebook. Okay? But the Pythagoras theorem relies on you knowing information. And so the key word, and I'd also like you to add it into your vocabulary at the end of your interactive notebook, hypotenuse. And this is how you spell it. It's the longest side on a right-angled triangle. And I'm going to give you a little picture so that you can also put a diagram in your journal. It's also found directly opposite the right angle. What is a right angle? Do you guys remember what a right angle is?
a 90-degree angle.
What did he say?
90-degree angle.
Okay. Here is a right triangle. Please go ahead and also make a quick sketch in your interactive notebook. Label the longest side hypotenuse and make sure you know which angle is your 90 degree. You can put a little box. This is always a good designation that shows if you're looking at a picture of a triangle, usually there's a little box that designates the 90-degree angle. And you can see that the hypotenuse is directly opposite that right angle. Show me on your fingers how much time you need.
1 minute.
1 minute, that's a long time. I like how you flipped it and made it the other side. It's great. Who remembers learning about the right angle yesterday? Yeah. Okay, here we go. Pythagoras' theorem. Which of these sides, and I would like you to use your whiteboard, which of these sides, A, B, C, would be the hypotenuse? And be prepared to let me know how you know, because you're going to prove it. Which of these sides is the hypotenuse, A, B, or C? Can you show up your board? Absolutely correct. Absolutely correct. And I like how you put longest. That's part of your proof. Can I see your board? Good job. Okay. Aiden, can you please stand and deliver and tell me how do you know that C is the longest side?
In the corner, in the bottom left corner, I can see that there's a 90-degree angle, and directly across from that is C, and that's the longest leg.
I think you proved it.
Yeah.
I think you proved it. Good job. Thank you. You're absolutely
Well,
correct.
it's on the opposite side of the 90-degree angle.
Opposite side of the 90-degree angle. I like that. Good job. Yes. That is a hypotenuse, so give yourself a pat on the back. You guys did a good job. How about this second one? A, B, or C? It's a different type of triangle. Looks a little differently. But which is the hypotenuse? A, B, or C? And Ivan, I would like you to be prepared to let me know.
It is C, because, like David said previously, it's on the opposite side of the 90-degree angle, and it's also the longest.
Okay, I like how you piggybacked on what Aiden said. Good job. You're all correct. Excellent. I like the drawings as well. Okay. Good job. C is the hypotenuse. Okay, things are going to get a little tricky. A, B, or C? Which is the hypotenuse? Why don't you show each other your board? You all have something different written there, and I believe you're all correct.
Yeah.
Christian, can you stand and deliver and let me know exactly how you know which is the hypotenuse?
I know because.
Which one is it? A, B, or C? Okay.
Because what Ivan and David said was a 90-degree angle, like the left top side. Then opposite of that is 8 is also the longest.
Okay. Opposite the right angle is A, and it's also the longest side. Good job. All right, go ahead and have a seat. Now that you know that, you can find the hypotenuse. We have to do a little bit of math and some calculation. So, the Pythagorean theorem, there's a formula to use to figure it out. And that formula, please write this down, as a squared plus b squared equals c squared. And if you look at the legs of a triangle, the two shorter legs, not the hypotenuse, are A and B. Generally, A is always listed as the shortest side, so you always want to list the shortest side first. It's a squared plus b squared equals c squared. And if you take a look at these squares, it kind of reminds you of some coordinate geometry we did the other day. You see a squared is 3 by 3. It's a perfect square. We learned about perfect squares. And b squared is a 4 by 4 square. And I'm going to show you a little video that's going to kind of show you how a squared plus b squared actually equals c squared. If you kind of take a look at the a squared and b squared, they can actually overlap and become c squared. Okay? The math is squaring the number. So 3 squared plus 4 squared equals 5 squared. And 3 squared is 9. 9 plus 16 equals 25. And what is the square root of 25? 5. When we get this back. Okay? So I'm going to show you. Whoops. Take notes if you need to. So there's a place. Okay, I would like to ask you to have a conversation with each other what you noticed about the video. What did you notice? Okay, good. And Christian?
It's supposed to be like all squares and all that, it's surrounded in a triangle.
Okay. So, oh, you mean that this triangle on the inside, everything's surrounding it on the outside?
Yeah.
Okay. Interesting. What did you notice, Aiden?
Well, I noticed that all the units from inside A and B, they both just combined and form C. So it doesn't necessarily have to, that size right there doesn't necessarily have to do that. But, for example, if A was like 4 to the power of 2, and then B to the power of 2 is 5, then it would get a little bigger, but then C would get a little bigger too.
Absolutely, and you guys are actually going to have to prove this. This is a proof that a squared plus b squared actually equals c squared. So you guys will be doing that in a proof. So good job. So now we're going to do some math. Here's an example. I'm going to kind of do it with you, but I'm glad you have your scientific calculators out. You're going to need those. To find the length of the hypotenuse, we're going to use the formula. And the formula is c squared equals a squared plus b squared. We kind of switched it around a little bit because we can, right? C squared is what we're looking for. Just like when we're looking for x in equations and expressions, we're looking for c. We know what a is. A is the shorter side. What is a? 15. So go ahead and plug it in. 15 squared plus 23 squared. 15 squared plus 23 squared. You may know what 15 squared is. You may not know what 23 squared is. 15 times 15 is 225 plus 529. And when you add that together, you get 754. Now, here's where you have to find out what that is. That's a kind of a large number. It's not a perfect square. We don't know what it is. That's off the top of our head. That's why you have your calculator. C squared is actually a root. C is the root of 754. So this sign is a square root sign. C equals the square root of whatever that number is. Okay, and so we're going to punch in 754 square root, and it's going to give you your answer. Go ahead and try it. Once you get it, I'm going to pop up and show you what I have, and we'll see if we're right. 27.46 thousandths. Is that what you got? And see, your calculator is going to show all the way to the thousands. We have 46 hundredths, right? So I'd round it up. We just round up. Always to the second decimal place. Did you get it? Thanks for helping him out. So we're going to go on to one more. Did you get the same thing?
Yeah, 27.
Did you find the square root symbol? There you go. You know how to do it now? Thanks for showing me. Okay, here we go. One more. Try to find the hypotenuse of this one. And don't forget to round your answer to the second decimal position. So we have the shorter side is what?
A squared.
A squared. And the longer side? Okay, you're going to look for C squared. Go ahead and try it. Using your formula. And if you don't know what 11 squared is, 11 times 11 you know. Multiplication mania. So 8 squared is what? 64. And 11 squared is?
21.
And when you add those together, you get? Is that a perfect square? What are some examples of perfect squares? 4 has a perfect square because the square root is 2. 9 is a perfect square because the square root is 3. 16 is a perfect square and square root is? Okay. This does not have a perfect square. If we end up with a decimal place, it's not a perfect square. Okay, so what did you guys get? 13.6. 13 and 60 hundredths. Okay, square root of 185 is 13 and 60 hundredths. Good job. I've got a couple that I want you to work on together. So I would like you to work on, since there's 3 of you, Hayden, can you do 1 and talk it out with these 2? Christian, can you do 2 and talk it out with them? You're going to do rally code. So you're going to talk about your thinking as you're solving it, and you're going to talk about your thinking as you're solving it, and then you're going to also do. So you're going to do 1, 2, and 3. Go ahead.